Looking at this chart, we've identified what all of the compounds are that have been crossed out and how to determine their pH in solution. We're specifically focusing in on the compounds that have the hydrogen inside their formula. And right now I would like you to pick out the molecule that we know for a fact could only be an acidic salt. Hopefully you found it identified right here. So let's take a look at that molecule in detail. That salt is 100% soluble in solution, forming two ions, one which will not hydrolyze and one which will hydrolyze. Now to determine whether that anion will act as an acid or a base. The reason why there is a question as to whether it can act as an acid or a base is because of the amphiprotic nature of that ion. It has an ionizable hydrogen, but it also has the ability to accept an additional hydrogen. So our question is, which would it prefer to do? Would it prefer to lose that last remaining H, or would it prefer to gain an H and turn into its conjugate acid? We can find HSO4- here. It's labeled a base. However, we can see that it's never going to gain that proton back to turn into H2SO4. So that ion acting as a base is not possible. It can, however, act as an acid, and it's not too far down the list, so it can act as an appreciably not strong acid, but close to the top. And so we could continue on and do an ice grid using this Ka value and calculate the pH of the solution using the X value that we would solve for and the Ka of 1.2 times 10 to the minus 2. I won't demonstrate that here because we've done many ice grids for weak acids and you should already know how to solve this question.